So we can use Venn diagrams to represent sets, and Venn diagrams are basically overlapping circles that are used to illustrate the logical relationship between two or more sets. And we are going to start working with them and see how we can use them to represent sets. So in the first, in question 3, we are required to illustrate each of the following on a Venn diagram. Now, if you notice, just by looking at set A and set B, we can notice that there's nothing in common. Yeah, but of course, set A is a subset of set of the universal set, and B is also a subset of the universal sets. All of them have elements from the universal set. So basically, what we can do is we usually use a rectangle to represent the universal set. And then in this rectangle, we'll have two sets in this case because there's nothing in common. That's why I have a gap between them. There's nothing in common between A and B. So this will be my set A and this will be my set B. So the elements in set A are 1, 2, and 3. You can just write them anywhere in the circle. And the elements in set B are 5 and 6. Again, you can just write them, any of them in the circle. But there's one element that's not in either A or B, but it's in the universal set. So we can just write 4 anywhere in the universal set, of course, to complete um, the two sets A and B and the universal set. And that's how you illustrate this on a Venn diagram. So for part B, we are going to do the same thing. So you start with the rectangle to represent the universal set. But now by inspection, we can see that set C and D have some elements that are in both. For example, C here and D. These two elements are in both. So when we draw our circles, we'll have them overlapping. And of course, this can be our C and D. Yeah. And then what we have in both is these two elements, C and D. And then, of course, D has only three elements, C, D, and E. But C has four elements, C, D, A, and B. And then there's one element that is not accounted for here, which is F. F is neither in C or D, so we write F outside the two circles. And our Venn diagram is complete. So in number 4, we have a Venn diagram, and we want to get information from this Venn diagram. So we are required to list the members of the following set. So the universal set, that's basically everything. So you have to list everything. And I'll try to list them from in ascending order from the smallest. The smallest number is 0, and we just read them. So we are listing everything in the this Venn diagram. So 0, then we have 1, 2, 3, 4, 5, 6, 7, 8, and then we have 9, and that's the highest number that we have here. And P, which is this circle here, has the following elements: 1, 2, 3, 4, and 5. And Q, which is the remaining circle, this one here, has the following elements: 4, 5, 6, 7, and 8. And you can check that. And then what is in both P and Q is just 4 and 5, two elements, so 4 and 5. And then if we list everything, that's contained in P and Q. So that will be just everything in these two circles, everything. So that will be 1, 2, 3, 4, 5, 6, 7, and 8. Um, now this is called the union. Yeah. Part D is the intersection, and then part E is the union of both of these sets. We discussed that previously. And then these are elements that are not contained in P or Q. Yeah, we can say that these are basically the set of elements that do not belong to P um, or not to Q. Yeah, so basically everything that's outside, basically everything that's not in this, yeah, everything that's not in this set here, but of course is in the universal set. Yeah, so that will be 0 because of 0 is not in this set here, and also the other number is 9. 9 is not in this set. Okay, and then number 5, we have the universal set representing whole numbers. This goes up to infinity. And then set A represents factors of 100. So let me just list those factors. So factors of 100 are basically, think of numbers that multiply to give 100. The smallest number is 1, because 1 multiplied by 100 is 100. And then you have 2, and then you have 4, 5, 10, you have 20, 25, 50, and 100. So these are factors of 100. And then multiples of 5. 5 multiplied by 1 is 5, 5 multiplied by 2 is 10, and so on. So that will be 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, and we have 100, yeah, and this goes on and on up to infinity. All right, so we want members, we want the elements that are in both A and B. Yeah, so we want elements that are in both A and B. Now, by inspection, you can notice that 5 is in both A and B, 10 is in both A and B, 20 is in both A and B. We also have 25 is in both A and B. We have 50 is in both A and B, and we have 100. So this will be given by these elements, and we just need to list them because it's a set of elements that are in both A and B. We have 20, 25, 50, and then 100. Okay, number 6. Um, so which of these Venn diagrams illustrate the pairs of sets given below, where this is a set of whole numbers? So the universal set is a set of whole numbers. All right, so part A, we have set A being even numbers and set B being multiples of 4. Now note that set B, which is multiples of 4, is a subset of set A. Yeah. So which means, of course, you know that all multiples of 4 are even numbers. So B is a subset of A. So this is clearly this Venn diagram. So this is B, and that is A. And then here we have even numbers and multiples of 3. We know that some multiples of 3 are also even numbers, like 12, yeah, 18. Those are even numbers. So we can say uh, they have things in common. So C and D have things in common. All right, and then part E is odd numbers and even numbers. These guys here, they can't be this. They don't share anything in common. Any odd number will never be an even number, and any even number can never be an odd number. So this is basically represented by these two circles. You know, they don't touch, they don't intersect, so nothing in common.